Okay, thank you. Okay, on behalf of the Department of Computer Science and Engineering, I welcome everyone to this webinar. Title is Road to 6G. Let me formally introduce our speaker today. Dr. Mamta Agiwal received her PhD degree from Sejong University, South Korea, and MS degree in Digital Electronics from Visvesvaraya Technological Institute, India. She is currently working as an assistant professor with Sejong University, South Korea. Earlier, she worked as a postdoctoral researcher with Hanyang University, South Korea, and an associate professor with the CMR Institute of Technology, India. Her research interests include 5G and beyond 5G, wireless communication, energy efficiency, and Internet of Things. So, one of our related article to today's webinar will be Next Generation 5G Wireless Network, which was published in 2016, has received more than 2,800 citations according to Google Scholar. In her recent work on 5G includes dual connectivity, paging, directional reception, spectrum usage, IoT, D2D, and random access. So while we are going to start using 5G in India as well as in Odisha, we are in early days of starting to think about 6G, and I can think of no one better than Dr. Mamta Agiwal for this webinar. Welcome, ma'am, and please start presentation.
Thank you, Dr. Bharat. I'm so happy to be here today and discussing on 5G and 6G wireless communication. Am I audible?
Yes, audible.
Okay, I'm sharing my slides here now. I guess everybody can see. Okay, let us begin. Hello?
Hello,
Okay,
yes.
I'm starting now then. Okay, so thanks for introducing me, Dr. Bharat. And uh, for me, 5G and 6G is my passion. In fact, I started working on 5G and I started reading about it when the word 5G was not even coined. Back in 2010, 2011, somewhere around that, I was studying on wireless communication and how it works, and I was studying about how to save energy in wireless communication. And while reading, I came across a topic that how to how to increase the data rate in wireless communication. And that's when I learned that people like Rappaport, whose books we have been reading, or people like those, they were working on millimeter wave technology. And that is how I got introduced into 5G and 6G. And since then, I've been very fortunate that I've been in South Korea, the country where all these things, the wireless communication is at its peak. Okay, so let's start for today's presentation. 6G, a road to 6G, right? So this is I like this slide very much because this shows in 1947. This was the first paper. This was the first paper that was written on wireless communication back in 1947. Why this is important is this was the figure in that paper, and these were the authors, and this is how it was written. Of course, back then it was not digital, it was all on the paper. But the idea is it was written in 1947, and the first wireless phone, that is 1G phone, we don't even use that term any longer. That 1G phone came in the year 1973. This is Martin Cooper making a call, I think, to the then Prime President of United States. So see the difference here. From 1947 was the first paper, and then the first phone was developed in 1973. So even though 5G communication is still at its infancy, we can say that it's not early to already start talking about 6G communication, because when the research starts and when the actual commercialization takes place, it takes time. It does take time. And if we see the trends, say it usually takes around 10 years. So say in 1980s, this is an example of the first commercial launch of 1G phone in 1984. So somewhere in 1980s we had 1G, and then 1990s 2G, and so on. So since 1920s was when we had 5G communication started, at least the NR part of 5G started. So in 2030, we can look forward to 6G communication. So it's not early. Uh, Rather, I can say it's slightly late that we have started to talk about 6G communication now. So how we are talking about road to 6G. So how have we come here? So we started with 1G communication. We usually do not even read about 1G communication. So there it was mostly about sending messages or making calls. So as you can see, the size of the phone is enormous here. So this was 1G communication. Of course, we have come a long way from then, right? And then I am from the generation which used 2G phone, and that time it was very popular. It was a status symbol to have a 2G phone. So we had those Panasonic phone or the Nokia phone with huge antennas, and the only thing that we could do was to call our parents, and that too the calls were expensive, so it wasn't easy to make a call or maybe send a few messages. So it was more to show off than to actually use it. And then as the time became faster, we came to 3G communication. I still remember one of my friends showed me Aaj Tak video on a 3G phone, and back then it was a very big thing, and I'm not that old, right? So it wasn't a long time back. That was somewhere in 2000s, and then after that there was a boom. So it was 4G communication where actual communication became a mass communication, right? So with Reliance in India and with other service providers, so 4G has penetrated into the market very quickly. One of the things about 4G is that it provides very fast broadband. What does this mean? Very fast broadband means that I can see the videos online. So that is what revolutionized the wireless communication. that you have access to videos, to huge amount of data, and at a very good pace. Imagine that if you are having a very high broadband connection, you have access to lot of videos in the world. But when you actually start to see the video, then you get that symbol, right, where it is loading and loading and loading. So it takes time. You do not like those kind of videos. So 3G was that kind of communication. But when 4G actually came, it started with a very fast mobile broadband communication. And then, few years back, around 10 years back, people started talking about 5G communication, enhanced broadband communication, very low latency. So this is how is the road to 6G. And if you see this growth from here to here, this has been very quick, right? We started from 1980s, and usually in a time of 10 years, we can see a new generation coming. Now, the idea is, okay, 4G was good enough. Why? Why do we need 5G? Or today, as we are talking about 6G, why do we at all need 6G? Right? You may ask me these questions. Uh, See, my internet looks like slow.
It
Uh,
is audible perfectly.
yeah. So yeah. So these are the drivers. So I was talking to that 4G was working perfectly fine. Why we are talking about 5G? Why we are talking about 6G? Okay, I understand 3G. I was not able to see a video. So 4G gave me access to I can play video games. I can play YouTube channels. So why I need 5G? 4G was enough. No, 4G was not enough. Why? Because when you see 5G, 5G added to the wireless content all the digital industries. What are the digital industries? It's not only YouTube videos or the music videos that you are watching. You are doing shopping. You are sharing your finances. You are reading magazines. You are watching sports events which are live. Now, live means it has to be fast and the data also has to be very high. It's a lifestyle. You are playing games with, maybe you are sitting someplace in India and you are playing with your friend in US. So that kind of resources that were not provided in 4G communication, 5G offers to provide those kind of resources. 5G offers to provide those kind of resources. Now, when we are talking of 5G, 5G is a digital industry, right? You know shopping, you know entertainment. Instagram, you are sharing videos with your friend. You are making reels, sharing reels. You are making videos, sharing video. Uh, you are live. You are putting your live stories on Instagram. There's so much you are doing these days. But this is all digital industry. This is all digital industry. When we talk about 6G communication, we are trying to incorporate physical industries into wireless communication. What are physical industries? Physical industries like transport, physical industries like military, physical industries like oil and gas, physical industries like water, electricity, all your utilities, physical industries like mining industries, physical industries where you are having telemedicines, you are having hospitals, you are having labs. Interestingly, if we see the investment here, if we see the investment in ICT today, ICT is Communication and Telecommunication Department, 70% of the revenue comes from digital industries. 70% of the revenue comes from digital industries, right? Whereas if we consider the GDP of any country, most of the GDP comes from the physical industries. And as of today, physical industries are not very appeased with wireless communication. Wireless communication is still at very, very basics when it comes to physical industries. Like you do not see, say, if any of your uncles or your fathers or your relatives are into the business of transportation, you don't see them using wireless communication to track their goods or to track their vehicles. It's not very popular as it is popular in every day-to-day life. You would have heard of this word IoT, Internet of Things. What is Internet of Things? Try to connect everything. So before 5G, we were trying to connect humans. In 5G, we are trying to connect Internet of Things. Everything is connected. Say your phone is a smartphone, your refrigerator is a smart refrigerator, your washing machine is a smart washing machine. You can control your washing machine through your phone. You can control your uh, wireless vacuum through your phone. You can have your air conditioning control through your phone. So Internet of Things, where the things are connected, was very popular, has become very popular in current scenario. But when we are trying to connect these industries, when we are trying to connect, then we move from IoT, we move to the next term that is called as IIoT. That is industrial Internet of Things, right? Because as you can see, these are physical industries. So we are moving towards Industry 4.0 or IIoT, that is Industrial Internet of Things. The idea is to relate all these physical industries, physical production, physical operators, all these things. We are trying to make them smart and trying to make them wirelessly connected. That is the aim of 6G, right? So it's basically you are trying to move from digital to physical world, right? And for that, of course, you need digital technology. Along with that, you need so many other elements. You need machine learning, we need big data. So together, all these things, when we put together, we can come to a world where we are having uh, industrial Internet of Things. So in fact, 3GPP is a standardizing body which standardizes standards for wireless communication. In a couple of years back, it came up with its Release 16 package, and Release 16 package included Internet of Things, and that was I'm talking couple of years back. So that was in Release 16. Release 17 is already out. Work on Release 18 already started. So the research industry, the wireless industry is already moving towards 6G communication, right? So the idea is to connect industries, to move from human centric to machine centric to actually connecting the physical worlds together, right? So so if I put it in a nutshell, 1G was mostly in sending messages and all. 2G was actually talking talking on the phones, right? It was mobile for voice, for any kind of voice communication. 5G introduced to some kind of visual telephony, and then with 4G we had internet, right? Internet on phone. We had YouTube, we had music, we had Instagram with 4G. 5G started working on connecting things, right? Making it more holistic. And with 6G, we can say it's a mobile communication for machines. When I say machines, I mean physical machines, physical industry. So 6G technologies will specifically develop for hundreds of machines, not hundreds, I say millions and billions of machines connected together. So when I say machines, so please understand when I say machines, machines means connected. Of course, computer is also a machine, right? You can say your phone is a machine, your computer is. I am talking about heavy machines here. When we are talking about 6G, the main users would be physical machines like vehicles, like drones, like your home appliances, any kind of sensors installed in infrastructure, in your bridges, in your ships, in your satellites. So these kind of construction machines that you have some oil refinery is there in the middle of Pacific Ocean. How do you make it wirelessly connected? How do you make it smart? So these kind of things will be provided by 6G communication, like all the factory equipments. So whether it is what do you say, conveyor belt, which is uploading the raw material, or if it is you are moving the machines, or you are moving the material or fixed products from the industry to the storage unit to the market to the retailers, everything will be automated, everything would be wirelessly connected, right? So now you can imagine if everything has to be wireless connected, you need certain technology for that, and that technology is specifically being developed as a 6G technology that would be connecting billions of machines, taking into account the requirements of machines. Why? Because every machine will have a different requirement. the machine working in an oil refinery in the middle of the Pacific Ocean would have a different requirement. The machine which a medium scale industry is using, say for packaging their food or packaging their Maggie or packaging their potato chips, that machine would be very different, or their setup would be very different from the setup which is there for an oil refinery. Now you want to make oil refinery also connected, wirelessly connected and smart. You also want to make this kind of setup also wirelessly connected and smart. So you can imagine different machines will have different requirements. Take a MRI machines in some hospital. Now the requirement or what that machine is expected to do and take the image quickly and immediately send it to some operating table in some remote village in India, right? So imagine the kind of requirement. It would be very different. So different machines will be there. They will have different requirements, and 6G offers to provide those requirements. How does it offer? How does it offer? So what we have is one thing that we have is we have to have certain standards, certain key performance indicators. Till now in 5G, we had these kind of standardization. We had something called as narrowband IoT. Narrowband IoT. Now, narrowband IoT is very good because it allows a flexible development, and somebody somebody who has worked on NB-IoT would know it allows in extending the coverage. Extending the coverage means that if let us say this is my base station, normally this is my coverage with NB-IoT, I can extend the coverage area. I can extend the coverage area. So usually there are certain methods, repeated transmission or something like there are certain specific methods, and these methods were already defined. Now, when you are extending the coverage area, narrowband means this is meant for very small communication. Your data size is very small, right? For low device complexity. So when the device is very low complexity, you are sending very small data. Your main requirement is that you want the battery life of the device to be very high. So there were certain standards which were developed for NB-IoT. There were also certain standards which were developed for LTE-M. It was similar to NB-IoT for machines to talk, but in this case, it was comparatively higher bandwidth. So here, as the name suggests, here Here, as the name suggests, this is narrowband, and these standards were narrowband, and these standards are for comparatively higher band. So you can share more data. Narrowband means you can share less data. A little higher band means you can share more data. So if I am having a very small sensor, this is certain uh, field here. So this is some agricultural field, and I have some sensors in this field. I have some sensors in this field, and these sensors are going to send me data at some remote control location, which will show me that what is the moisture content in this soil. So those sensors will be very small sensors. They are in remote location. I do I do not want them to waste their battery. Just a small number would be enough, right? For such kind of requirement, this narrow band IoT, these standards, these specifications were enough. So when I say standards, you are specifying how will the things work, how will the technology works, how much would be the data size, how much time should it take from data to be transmitted, say from here to here. So such kind of environment where you are having a field, you are having very small environment, such kind of cases, narrowband NB-IoT is enough. Now there can be certain cases where you require more data rate or where you even require mobility. Say in the previous case, when we had this field and we had this sensor, the field is not going to move. The field is not mobile, right? The field is not going to move. But there can be certain cases where there is little bit of mobility and you need higher bandwidth. Say there is an ambulance and you want to track this ambulance, right? So ambulance is moving and there is a patient in the ambulance, and ambulance is taking some ECG and sharing the data with the doctor before the patient comes to the hospital. So it is mobile and it requires a little more bandwidth than the narrowband bandwidth. So we had specification for these kind of use cases. We had specification for these kind of use cases, which was already there, which helped in this is an example of IoT. This is an example of NV. This is also an example of IoT. Now we are talking of IIoT. So for we have to move beyond the existing standards of NB-IoT and LTE, and therefore we are moving to the new standards of IIoT. How are these standards different? One very, very, very important difference between the existing standard and this IIoT standards, which will cater to physical industries and which will help in 6G communication, is very low latency and very high reliability. Very high reliability. If I see this number, you can, this, what does this mean? Say, I'll say, how many digits are there? One, two, three, 4, 5, 6, 7, 8, 9. There are 9 nines. That means if I have 1, 2, 3, 4, 5, 6, 7, 8, 9. If I have these incidents, in these incidents, only one can go wrong. That is the reliability we are looking at. That suppose some industry is sending data from some refinery in the middle of the Pacific to an office in Delhi. So if refinery is sending the information from Pacific Ocean to some ministry in Delhi, in these many data transmission, only one maybe can go wrong, right? So that is the reliability we are looking at. That is the reliability we are looking at. This is a very high reliability and this is a very, very low latency. What is latency? You can consider something like this that suppose you are watching a video, right? You are watching YouTube. You are downloading. So today you are in a mood to see um, some of the latest movies. You want to see Top Gun again. So what you are doing? You are watching the movie on the YouTube, but you are always getting this circle, right? That means its latency is very high, it's very slow. You do not like such kind of a communication, right? So you are waiting, then it's coming slowly, then you wait, then it comes again. When one scene comes, then it waits for some time, then it comes. Okay, it's very irritating. You may or may not see the movie. Now imagine there is a patient in some remote village and there is a robot doing some operation, and that robot is controlled by a doctor. That robot is controlled by a doctor sitting in a very remote location. Now now imagine that the doctor is giving certain instructions to this machine or this robot to operate on the patient, but it is low. It is low. Latency is very high. It is low. You just cannot afford low latency in this case. Why? Because if in this case, if the internet is slow, your patient might die, right? The the requirement is in the extreme. So when we are talking of 6G communication, we are trying to achieve this kind of scenario, right? This is the difference between IoT, which was in 5G, and IIoT, which is human centric. I Between IoT, which was in 5G, and IIoT, which is the crux of 6G communication, right? So now, before just a moment, yeah. Why? Why? Why do we need such high thing in a machine? So here you can see that human eyes are capable of some things, right? But a machine can do more than what a human being can do. Say, for example, I can turn my neck from right to left, right? Back? Can I turn my neck back and see? No, I have a limitation. If you are designing a robot, if you are a machine, you can design it. You can design it to see right. You can design it to see left. You can design it to see front, or maybe you can rotate the head of the robot to go behind also, right? So these kind of limitations are not there in machines. Similarly, with my eye, there is a distance that I can see. There is a distance that I can see. Beyond a particular distance, I cannot see anything clearly. Now imagine that you make a robot, and in that robot you put a very high quality telescope. So that robot will be able to see to a distance which is far more greater than what a human eye can see. Right? If I am physically not capable of doing the things very quickly because there is a limitation. I pick up a phone or keep a phone, I will take some time. Or if I'm blinking my eyes, I'll take some time. But imagine when you are designing machines, machines can be designed to have a much higher limitation, exceed all human limitation. As a human being, I can listen to only certain frequencies. I cannot listen to the frequencies of certain dog whistles, right? But a machine can. A machine can have a higher viewing angle. A machine can have very, very low latency. A machine can have a higher resolution. So the, the possibilities with machine type communication are enormous, right? So that is why we are moving from 5G to 6G communication. In 6G communication, of course, we are talking of hyper connected world, and here we are talking of very high requirements. Now, if I gave an example that where there is a robot or a machine doing operation on some patient in a remote village which is controlled by some doctor in some city. So if you want this kind of communication, you want latency and you want a very high data rate. Very high data rate. Also, since we are expecting to connect everything, we are connecting, okay, of course, human beings have phones and some of us are having more than one phones. Then we are trying to connect all the machines in our house. I'm trying to connect washing machine. I'm trying to connect refrigerator, my phone, my light. Then I'm trying to connect everything in the house. And now I am also trying to connect big machines. I'm also trying to connect satellites. I'm also trying to connect ships in the ocean. I'm trying to connect refineries. I am trying to connect trucks. I am trying to connect whatever crosses on infrastructures on the roads. I'm trying to connect aeroplanes. I'm trying to connect big industries, refineries. I'm trying to connect all the transmission towers. I'm trying to connect all the generating stations. I'm trying to connect all the industry. So imagine how many connections will be there. How do you support such connections? You have such dense connectivity. So it's reliability, it's latency, it's dense connectivity, and of course you need data. You need data. Right? So for all these things, these are the requirements. We are shifting towards these requirements in 6G communication. 6G communication. If I compare the requirements of 5G communication from 6G communication, I'm not even counting 4G. Huh? 4G is the thing of past. We are moving ahead. So first of all, I need very high data rate. How can I get very high data rate? I remember when I was a child, or I think sometimes today, recently also, 100 Mbps was considered as a good speed, right? With 5G, we are talking about 20 Gbps. With 6G, we are talking about speed of 1000 Gbps. How can such high speed be provided? Such high speed can be provided because of, okay, carrier frequency. What happens is some of you who have studied wireless communication say this is the base station, this is the phone. Now, how is data transmitted? Before that can be wired. Before that to your backbone can be wired, right? But here this is all wireless. When I say wireless, there are certain special signals. We call them as carrier frequencies. The data, the information that we want to send on this phone is put on these carrier frequencies, and these carrier frequencies are capable of transmitting or the data from this base station to the mobile phone. Now they are certain specific carrier frequencies. They are certain specific carrier frequencies. Say to understand, you can think like that. Say I am talking right now. I am talking. So my when I am talking, of course, that is also certain frequency. Any audio is at certain frequency. Now when I am talking, if I speak from Korea and there is no device, can you hear me in India? That is impossible, right? Why? Because when I am speaking, the energy in my voice cannot take my audio after a distance, because the energy in my speech signal will fade. So what I do is I put my speech signal on certain high frequency waves like this, right? And then these waves are capable of covering long distance, right? So till 4G communication, we were using these frequency, this carrier frequency in sub-gigahertz frequency range, in sub-gigahertz frequency range. In MM wave, we are using much higher frequencies, much higher frequencies. If this is sub-gigahertz, then your MM wave will be much higher frequencies and terahertz will be even more higher frequencies. So when we were considering 5G, we were considering frequencies, this carrier frequency in MM wave range. And now when we are talking about 6G communication, we are talking about frequencies in the terahertz range. Terahertz range. Now, one of the problem with high frequency is as the frequency increases, the distance that is being covered decreases. So if 4G was able to cover some distance, let us say 1 kilometer, in 5G, if this is the base station, then the base station distance reduces say to few hundreds of meters, and for terahertz it's even less. What does this mean? That means that if it was 4G communication, need to have another base station after a kilometer. In 5G communication, I need to have another base station after few hundreds of meters. And when I'm talking about terahertz frequencies, then maybe after few meters, I maybe few tens of meters, I need to have a base station. So you will have very dense connectivity, right? So that is one of the main difference that we are having. That that here from 4G, from 5G to 6G, we are trying to use higher carrier frequencies. 5G proposes to use MM wave, 6G uses terahertz frequency. Because of these high capacity carriers, 5G can provide data rate up to 20 Gbps and 6G can provide extreme data rates, 1000 Gbps. Now 5G can provide this much reliability. 6G is expected to provide this much reliability. I hope you understand the difference now, right? Now latency, 5G is expected to give a latency of 1 millisecond. 6G, we expect the latency to be even less, which becomes crucial when we are talking about satellite communication, when we are tracking aeroplanes moving at the supersonic speed, right? In few microseconds, the position of the plane would change, right? You cannot have that risk. The latency has to be very, very small if we are hoping to connect uh, and automate all the industries, right? And of course, density. Density, we are talking of billions of connections. Why? Because as I told, we are telling connect everything, right? So how do I achieve? Okay, I understand. This is what we are looking at. Right? On paper, it looks very nice, right? 1000 Gbps data rate, very high reliability, very low latency, hundred millions of connections. How do I achieve this? How do I achieve this? As I told you, one of the method of improving capacity is to improve the frequency. To improve the frequency. So we are trying the carrier frequency, right? The carrier frequency, the spectrum, the carrier frequency. Call it a spectrum. So we are moving carrier frequency from 10 gigahertz to 100 gigahertz now in 6G, probably in the range of terahertz. The carrier frequency in the range of terahertz. So when we are having very high frequency, then we can provide higher data rate, right? Now, when higher data rate can be provided, we can talk of TBPS data rate, TBPS data rate. And as I told you, that since frequency is high, the distance between base stations reduces. So what happens is we'll have smaller cells. But when we have smaller cells, we have to make sure that these smaller cells are at low cost, And then the technology that is helping us build smaller cells at low cost is your hardware industry. Hardware industry is also developing. Your chip industry is developing, right? All the world is going for chip industry. So we are moving from hundreds of meters in 6G communication, maybe we'll move in the range of tens of meters. I'm waiting for this to go on the next slide. So it is coming like this. So that is why we need 6G communication. Ah, I'm still okay. Okay, sad that this is slow.
Yeah, a little bit slow, but I think it will improve.
Waiting for it to go to the next slide. Let's hope it does. Yeah, we are here. Okay, we are here finally. So here, this figure shows that how, okay, I said smaller distances, right? Smaller distances. Another thing that happens is that in LTE communication or in 4G communication, we had frequency in the range of this, right? So then we had 6 gigahertz and more than 6 gigahertz, say up to this gigahertz or up to this gigahertz, we are having 5G communication. Now, one thing is that the cell size is decreasing. Another thing is that when the cell size is decreasing, what we are trying to do is we are trying to have a beam-based communication. Beam-based communication. Sometimes your professor will use pointers in the class, right? They are beams. The best communication would be that if I am a mobile phone, I have a dedicated beam from here. And what happens because of that dedicated beam? Say, imagine this is user 1, this is user 2, this is user 3, right? So this user is having a dedicated beam, this user is having a dedicated beam. So what will happen now? There will be no interference, right? This signal is not going to interfere with this signal, is not going to interfere with this signal. This can be said as an example of a spatial division, right? So in from 4G to LTE, because we are using very high frequency range, it is become it becomes necessary that we use beam-based communication. To use higher frequencies, it becomes necessary that we use beam-based communication. So gigahertz frequencies, which 5G is using, or terahertz frequencies, which maybe 6G would use, all communication will be beam-based communication, something like this. So because we are having beam-based communication, the technology is going to change. Till now, sorry, till now this was your base station, and the signal will be transmitted all over the space. This was called as omnidirectional communication. But with 5G and 6G, we'll only be at high frequencies. We'll have this kind of beam-based communication. Okay, first we understand if I come here, so I need higher data rates, right? And I need more density. This can be supported by higher spectrum. And for higher spectrum, we are moving to gigahertz frequencies, and maybe we plan to move to terahertz frequencies. When we move to higher frequencies, we are talking about smaller cells and spatial use, and we are also talking of extensive beam-based communication. So all the papers on 5G or 6G that you research papers, if you read, they'll talk of beam-based communication. Again, oh, this is bad. I should wind up in some time. Other than that, we have high reliability. How can we achieve high reliability? Maybe something like this. You can consider duplicate packets. Say say small base stations, right? So say in hundreds of meters. So this is your mobile phone. Probably you can have same data packet from here. You can have same data packet from here also. So we are adding redundancy. If you send from more than one path, duplicate packets from more than one paths, then you can have higher reliability. And how can I have low latency? Okay, low latency I explain in detail. So low latency, one of I have this slide. I'm coming to that slide. So this is very important. This is very interesting and this is very important. How do I come to low latency? I come to low latency like this. So when we were having 4G communication, I told you we are having smaller frequency, carrier frequency was small. Since carrier frequency was small, so we call something called as bandwidth. A set of frequencies, the range of frequency is called as bandwidth. Say I have frequencies from 800 megahertz to 850 megahertz. This is called as bandwidth. Right? In LTE, say this was the range. In In 5G, my range can be say from 6 gigahertz to 30 gigahertz, right? So this becomes my bandwidth. I have more bandwidth, more frequency. Now this, as a kid in high school, you would have studied this relation. F is equal to 1 by T. What does this mean? More frequency means less time, less time. So between the signal packets, or between, we call them as symbols, don't go into the details, but in a bigger picture, you can understand. More is the frequency, smaller is the time. So when we are talking of higher frequency in 5G, in beyond 5G, or in 6G communication, we can have higher bandwidth. So here I have a bandwidth. There are different possibilities. So this is LTE. LTE was using something, sub-carrier frequency, or don't go into the details, something in 15 kilohertz range. 5G can use 30 kilohertz, 60 kilohertz, 120 kilohertz, 240 kilohertz. So you can see when this is my frequency, this is the time in slot, which is 1 millisecond. As my frequency increases, my slot time decreases. When my slot time decreases, what is happening here? Very high data. See, you can say very high data because there is not a frequency I can send in a very small time. So you achieve low latency. Then achieve low latency. And of course, then there are different scheduling methods. There are different scheduling technologies. People are researching on that. Work is going on those fields. Another important thing that I like to stress here is that in LTE, this was fixed. Everything was fixed. 5G gives us a lot of flexibility. So depending on my requirement, say I can use this also, 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 I can use this also. Say I want to have communication for why? Because I want to have a communication with my refrigerator. I do not need such big data. I just need to set the temperature, and the latency is also not important. I don't care whether the fridge is telling me its temperature in 1 hour, or it is telling me its temperature in 2 hours. So I may use something like this. But when I want to use my communication to 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 track some kind of a patient in my family, then probably I need this kind of communication. So 5G give me a lot of flexibility. One of the very good things that 5G and 6G has, which was not there in 4G, is that the terminology, this kind of numerology is very flexible. There are lot of possibilities, right? Then uplink also you can prioritize. So different communication applications can be given different priorities. The smart homes can be having less priority, or surveillance of a kid's school bus has high priority, right? Healthcare has high priority. Smart cities has high priority. So different things can be given different priorities, and based on these priorities, they can be given different kind of bandwidth and different kind of scheduling and different kind of data rates. So that flexibility is there, and that flexibility is very important because we are having variety of connections, right? Duplicate messages, packet duplication, I have already told you that instead of getting from one base station, there are 3, 4 base station, you are getting packet from here also, you're here also. So your redundancy is more, packet duplication is there, and you can afford packet duplication because you have very high data. You are having terahertz frequencies, then why not? Right? So with this, another thing that is important is you are trying to do processing near the phone. Say in LTE, this was mobile phone, this was base station connected to some kind of wired network and some kind of data center somewhere very far. Now these days we are trying to bring the data center here. And remember, I told you the base stations are also very near. So you're trying to bring the processing at the edge so that the latency becomes less, the delay becomes less, right? Now, of course, we have talked about so much of 6G communication. Of course, one of the applications I have put in IIoT, but uh, for us, right, we always want more human beings. What do we get more from 6G? We get mobile holograms. Now imagine I am sitting in Korea and giving presentation. After a few years, it may happen that my hologram will be present in your auditorium and giving you the presentation there while I'll be speaking from here, right? So, very high fidelity mobile hologram. That is one of the applications that we can think of. Extended reality, right? Everything connected. You are having virtual reality. You are having mixed reality. You are having other reality and many critical applications like telemedicine, communication. So the idea behind 6G is leave no one behind, right? Leave no one behind, whether it is natural resources, commodities, human to machine interface, transport, food. These are some of the things. We are researchers, right? We can think of hundreds of things. You can think of a problem in your area. You can think of how latency and data rate can address that problem, right? So another thing very important in 6G communication is AI. We are okay till now it was okay. Now to 6G we are also trying to add intelligence. Intelligence. Now why this intelligence is important, I'll tell you in a minute. But if you see this diagram, we are here. Currently we are here in this range. This is the range of latency and this is the range of data rate. Now there as we think of these applications, more and more applications, we can think of higher latency. This is when I say lower latency. So this is in microsecond and very high data rate. So we can think of vehicular connection. We can think of satellite communication. Or here, if you see satellite communication or vehicular communication requires both very high data rate as well as very low latency. Some applications, say for example, some kind of a system control. Say you want to control some conveyor belt in some industry. Maybe you require very low latency, but you do not require very high data rate for that. So some kind of applications would lie here, and some kind of applications, say for example, 360-degree view of a video, right, will require both high data rate as well as low latency. So we are still here. This is the range. We have to extend here, here, here. So you can imagine the possibilities are enormous as we move from 4G to 5G to 6G. The world is going to change, and there are, when I say change, it's a good thing because for us as researchers, there are a lot of opportunities. And another field that is contributing to 6G communication is AI and wireless tools because till now imagine you add intelligence in this, then the quality of the system will become very good, and also it will affect the latency. So every time a car has to take a decision to take right or to take left, the wirelessly connected car, it doesn't have to go to the base station for the processing. Because of the AI technique in the car itself, the wireless car can decide whether to take a right or a left. So that is again another aspect of AI communication. So I think we are running out of the time. I would really love to talk about AI probably in the next series of this section. So putting it everything together, when we talk of 6G, we are talking of a hyper-connected world where all things are sensed, where all things are connected, and all things are intelligent. I'm sorry I couldn't cover much on this part, but again, this is also a very important part. So when we talk of AI, we'll first have intelligent systems, then we'll have intelligent distributed computing. Say this was a base station, this is a base station, this is a base station, some kind of intelligence computing at the base station. And remember, these base stations are in a few meters of the distance. So you have distributed intelligence at uh, distributed computing systems, right? And then you have intelligent physical acquisition. Say you are collecting data in your agricultural field. You are you are having sensors in transport. You are having sensors in metros. You are having uh, sensors in your cars, in your buses, on the roadside. So that kind of sensing, right? So we have a hyper connected world. And with all these things, we create a nervous system, right? Like human nervous system. We create a smart, intelligent human nervous system. So 6G is a network with the sixth sense. So with that, I'd like to complete this. These are some limitations of AI. So we are not discussing today, but you can go through them. Limitations is a good word for researchers, right? For us researchers, limitations means these are the research area. I can work on this area, I can work on this area, I can work on this area. Okay? So in summary, in 6G communication, it's the specifications have to be very detailed, right? For what application, what latency, what data rate, how you are getting that latency, how we are getting that data rate, what kind of AI model I am going to use. So specifications, hyper specification, define everything, right? 6G is going to be hyper capable. It's going to be hyper diverse because you are talking of connecting a refrigerator. You are also talking of connecting a, a virtual operation theater for some kind of patients, right? So the requirements are diverse. So hyper diverse and of course hypersensitive. We are trying to connect everything. We are trying to sense everything. So it extends from humans to machine and we are talking of a hyper connected world. So I think I've taken enough time. With this, I'd like to wind up. Thank you so much. I'm available at this address. If you have any question, you can ask me now or you can email here. This is my address. Thank you so
Okay.
much.
Thank you, Dr. Agiwal, for the nice talk on 6G. Usually we open this forum for students, but since the topic is very interesting and we are trying to start a 5G lab on our own, many professors, including our Pro Vice Chancellor, Professor Pikinanda is here, and Joint Director from TRAI, Dr. Subodh Pusti was also with us.
Hello, sir.
So, Professor Pikinanda, please, some words. Sir, you are on mute mode. Please unmute.
Oh, okay,
Oh,
okay.
okay.
Okay. I think it was very interesting. I was listening to the lecture, and I think kind of we are on 5G. Start thinking of starting 5G now. You spoke on 6G, and yes, there's a lot of challenges. Also, you spoke very nicely. I believe if you want to enter into 5G, then I think 6G will be inevitable. And definitely 6G is going to come because, as you told, AI, machine learning, and all issues of latency, issues of an industry automation, and all autonomous vehicles and healthcare. I think these are the demanding things, and smart agriculture as well. So these are some of the things. Very nicely, lucidly you have presented. We do appreciate your kind of the work, and thank you very much. Thank you on behalf of the university. I thank Dr. Bharat also who arranged this lecture. I believe we will have several such lectures on this. We should have 6G
Yeah.
more. Maybe one issue we can have little more lectures. Maybe when you are free, we request you can educate us. Like it will be benefited that people will listen on this.
Sure, sure, sure. I'll coordinate with Professor Bharat and
Thank
we'll
you.
try to find out time.
Thank you. Thank you.
Okay. Thank you, sir. Dear professors and students and interested engineers, may I ask any question? And ma'am, there is one question. In India, we have issue with network connectivity and coverage. Can 6G in a way address issue related to the network coverage as well? This is a question from Dr. Madhuri Rao.
Why not? That as I was telling you, it was maybe 10, 15 years back when I was trying to watch a Aaj video on a 3G phone. Hardly I could see anything. From there, we have come a long way, and I'm sure the country is investing. Technology is developing, so it might take a little longer to implement, but once the technology is developing, once the standards are there, I think of course there is a possibility of better connectivity. So let's hope for that. And
Mm.
in
And,
in 4G also, because 5G I hope will be better than 4G because we can provide higher data rates so that connectivity issues should be resolved later on.
and another question from our PhD scholar Julius Gottschalk is what are the health considerations for 6G, mostly in spectrum?
Six because terahertz frequencies are still under study, and I think sometime back there was questions on millimeter wave also when 5G was implemented. So that time some of the researchers in New York University, again under the team of Rappaport, you can see they have published some articles which says that no such things were found. We do not know what happens in future, but there are certain articles in IEEE Spectrum which talks about which have done studies on what are the health effects of waves, and they were found that till now nothing serious was found. I don't know what happens in terahertz. I'm sure there would be some researchers working on that, and we can hear about it in future also.
Thank you, ma'am. Any other questions?
Yeah, good evening, ma'am. Am I audible?
Yes, please, you can go ahead.
Yeah, actually, for the 6G communication, connected cars, definitely a lot of applications are going on nowadays.
Okay.
So my question is that if we are going to discuss about the ad hoc networks, so any security issues will be there, particularly with the 6G and connected cars?
Yes, I have not touched upon that part, but because we are talking about health, we are talking about everything connected. So of course, everything is prone to security. So there are certain research or there are certain specific specifications in 3GPP which are working on security, only security related issues. Say for example, I am a hacker. I'm talking about there are base station after few meters, so you can have your own base station and then you can hack the data, and you can have a faulty base station or you can have a false base station. So you will see there are certain specifications, there are certain security standards which are trying to work on those areas as well. So there is a lot of research in going on in those areas as well. So when we are talking about 5G or 6G, these are also the important topics. I am not working on these topics, so they were not dealt in my presentation, but research is going on those topics as well. If you want to read about that, you can read about something like false base station, and you can Google and try to find out papers on that, research on that.
Okay, ma'am. Okay, ma'am. Thank you.
Okay. Can you please differentiate between B5G and 6G?
Okay, when 5G actually started, then millimeter waves are till now not commercialized. So we are having standalone 5G communication, where we are having frequencies in the range of less than 6 gigahertz, or we are having a connection where the mobile is connected to both LTE also, and it is also connected to 5G. So from there we try to move to 5G communication, and in 3GPP release 16 and 17 was mostly based on NR, new radio of 5G communication, where we were talking about only standalone 5G base stations. Beyond 5G talks about IoT and tries to connect more devices and higher data rate. So if you consider non-standalone, maybe you can have data rate in the range of less than Gbps, standalone maybe in Gbps, beyond 5G in the range of 20 Gbps or higher carrier frequencies. So standards are being developed. So this B5G terms comes because of the 3GPP standards. So they have this specific words that new standards are coming to implement the 5G communication. So they use the word B5G. So based on that, you can find a lot of research going on in that direction. It is not 6G yet, but slightly more than 5G. The specifications are moving on because 5G is already the 5G standards is ready. So what is the next standard they are making is B5G, based on B5G. And there is another word you can find out is advanced 5G.
6G is a concept we are not fully realized yet. So beyond 5G is more appropriate, that seems.
Anything that you can think of to wirelessly connect or to have that kind of connection, put it in 6G. It's your imagination. Let it run wild.
Okay, thank you, Dr. Agiwal, for the nice presentation and your time. So I think possibly when we have time, next time we can talk about the possibility of AI with 5G and 6G.
Yeah, sure.
From our Computer Science and Engineering Department of Sikha Anusandhan University, I extend our gratitude for your time. Thank you.
Thank you. Thank you, Dr. Bharat, and thank you,